Hello everyone. Welcome to the next lecture on the CSIR Net Mathematics 2025. Today I will explain you how you can solve the real analysis questions from the part C. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the various lectures such as the linear algebra, partial differential equation, numerical analysis and many more lectures related to the CSIR Net and the GATE mathematics complete solutions. Also you can see before the examinations I had uploaded the last minute real analysis and many questions were asked from this lecture too. You can subscribe my YouTube channel and watch my videos. Now, look at the first questions, how you can solve within the 1 minute. Remember, each question I have explained you with the help of the 1 minute time period. You may note it down the time period as well. Then consider the function fx. So what is the shortcut tricks? As I explained you in my this last minute real analysis and the other lectures. Whenever you have the function of sine x raised to power m 1 over sine of this, or whenever it's a x raised to power m cos 1 over x raised to power n, then this function is my continuous for all the values of the m and n which are strictly greater than 0. This function is differentiable for all those values of the m which are satisfying the condition m is greater than of n. Now you can see in this case m is my 2, n is my 1. So that means the function is differentiable. Fine. The function is also continuous. Fine. Limit x approaches 0. When you take limit x approaches 0, this function is my bounded. This approaches 0. Yes, it is existence and value is 0. What is the f dash? If you find the derivative, it will be 2x sine 1 over x plus x square. Sine derivative will be cos and the derivative of the 1 over x is minus 1 over x square. And clearly say this value will be cancel out. It is a 2x sine 1 over x minus cos 1 over x. When you take the limit x approaches in 0, this because of this x, this value will be the 0 and this limit does not exist. Fine. And he said does not exist. Yes, correct options. All A, B, C and D are my right answer of this problem. The same question I already explained in this lecture of the last minute revision of the real analysis. I hope you can watch and like and comment on the video as well. Okay, which of the following statements are true? Let x and y belongs to the R such that x is less than y. I can choose x is my 0, y is equal to 1. Fine. So that condition will be satisfied. Then there exists a real R. Then there exists a rational R such that this condition is satisfied. So your target is to prove whether this result hold or not. R over E is less than 1. Fine. So that's a very simple. You can multiply both sides by E. So it's a 0. 2 raised to power 4. R is less than E. And I can find the value of the R. So that will be 0. And it is E divided by 2024. Clearly say this number is also belongs to the R. So that means I can simply say 0 less than R is less than S, where S is my real number. Now we all know between the any two real numbers 0 and S, there is always exist one rational number. So that means yes, this condition will be satisfied. Fine. Or there is a one more method how you can prove that. Instead of taking x is 0 and y 1, we all know whenever there is a x is less than of the y. Fine. I can multiply both sides by e. Ex is less than of the ey because e is my positive number. I can divide it both sides by 2 raised to power 2 raised to power 2024 because this is my positive number. Now this element belongs to the R. This element belongs to the R. So between the two real numbers, we can always find one rational number, let's say called as the R, is here. Fine. Now once you can see, can you find the value of the x? It is again similar to the given requirement. So that means the first option is the correct option. Now look at the second option. an is the sequence of the positive real numbers. If there exists a positive real number L is a greater than 0, such that limit supremum an over log of n is my L, that is a finite number, and approaches infinity, positive real numbers, then this implies limit supremum of an is my finite. So I think that's a very simple, because you can see that it's a log of n. I can choose the sequence is log n. Then what is the answer of this case? This answer is 1. That is my L is my 1 and which satisfy the given requirement. But what is the supremum of the an? Which is my finite, and it is not less than infinity. So that means this counter example will discard the option second. Now look at the, firstly we can discuss the last option, a continuous functions from R to the set 0 comma 1. It's a continuous function, is infinite. That's a very simple. What is the cardinality of this set? Is a 2. Cardinality of this set is C. Now because it's a continuous map, I can choose any element of the X. Either it maps to the 0 or it maps to the 1. So how many functions are there? There are only 2 functions exist. Fine. So but he said infinite functions. So that option is cancelled out because the 2 function is my finite. Fine. Now look at the last option. Look at the third option. The set of all those finite subset. Let's say S is my subset of the Q. Fine. And it's a countable. Whenever you are talking about the countable, look at the cardinality. Cardinality of the Q is alpha naught. Now what is the subset of the Q? Either it may be the singleton, fine, is a finite subset, or it may be the A comma B, or it may be the A comma B comma C, or it may be the A1, A2, but it must be the finite. So A, N. Fine. What is the cardinality of the A? A is the subset of the Q. So it is alpha naught. What is the cardinality of this case is? Again alpha naught, or alpha naught into alpha naught, and so on. So again you can see it is alpha naught. How many finite subset you can consider? So that is always be a countable infinite. So yes, the set of all those finite subset of the Q is countable infinite. So A and C are the right answers. I hope you can like and comment on the video as well. Okay, what is given to you? F is a continuous function. F is a continuous function such that whenever x is less than 0, the answer is 0. Whenever x is greater than equal to 1, the answer is 0. And whenever x is lies between 0 and 1, the answer is f1. Fine. And make sure this is given as a continuous function, that implies f1 is my continuous. Is it okay? Now they have defined as the capital F, check whether they are bounded or not. So how you can check about the bounded? I can use this mod of F. This n approaches minus, so that means x plus n must lies between 0 to 1. Can you find the value of the n? It will be minus x less than of the n and less than of the 1 minus x. So that will be summation n is equal to minus x to 1 minus x. Fine. So that means this is the finite sum. This is the finite sum. Now f is a continuous on the closed interval. F is continuous on the closed interval. So that means f is my bounded. Fine. If f is my bounded, I can return this function is my bounded. It is less than of the m, because this is a finite sum. So finite sum is say called as the km. I call this number is m dash. So yes, this is my bounded. Is it okay? Now look at the second option, whether the f is continuous on R or not. So clearly say this is my, all us knows that the finite sum of the continuous function is also the continuous. Fine. So if f is my continuous, because f1 is my continuous, f is given as a continuous, finite sum of the continuous function is continuous, so that implies capital F is also continuous. Now, whether they are uniform continuous or not, now how you can prove the uniform continuous? Because f is a continuous function which are defined on the closed interval 0 comma 1 on the R. So once f is continuous on the R, that means f is my uniform continuous on the R. So that means third option is also correct. Fourth option is fine. There is one more way. If you prove that the function is continuous plus the function is periodic, that it implies the function is UC. Fine. So can you prove that the function is periodic? Or if in the examination they are said that whether f is periodic or not. Fine. So how you can check about the periodicity? So I can say x plus 1. So my target is to prove this is same as fx. So I can start from this f of x plus 1 plus n, where n start from minus infinity to plus infinity. Now that's a very simple. I can take 1 plus n to be another number, say m. So this, if n approaches minus infinity, m is also my minus infinity. Infinity is again, so it will be x plus m. So what does the meaning of that? This is my fx. So yes, f is my periodic function and f is my continuous function. We already proved in the second option. F is a continuous, f is a periodic. That means f is my uniform continuous. So yes, A, B and C are the right answers. Okay, look at the next one. A function defined as which of the following is differentiable, continuous and so on. Now, it's a very simple approach. X square y over x4 plus y square plus e raised to power xy. Clearly say this function is my continuous because every exponential part is my continuous. The only thing is we need to check whether this is continuous or not. What is the shortcut fix? As I explained you in my lecture of the several variable. You can watch the lecture related to the function of the several variable. Let me just, I will show you which lecture you can watch. Okay, I will tell you the shortcut fix here. Whenever you have the function of x raised to power a, y raised to power b, x raised to power c, y raised to power d, where all those a, b, c, d are my greater than 0, then the function is continuous if and only if x a over c plus b over d is my greater than 1. So you can see the lecture of the function of several variable. If you watch my these two lectures, this is the differentiability lecture, this is the continuity lecture, then you can see this is the shortcut fix. So if you look about that, 2 over 4 plus 1 over 2, which is not greater than 1. So that means this function is not continuous. That means f is not continuous at 0 comma 0. If f is not continuous, that means f is not differentiable. Fine. F is not continuous. F is not differentiable on R square because it is not differentiable on 0 at 0 comma 0. F is differentiable on R square minus 0 0. That means we are talking about apart from the 0 comma 0. Yes, they are continuous everywhere. Sorry, they are differentiable everywhere. So because it's a polynomial. Now check whether they are differentiable. Whether, so this option is the correct. F is not. Fine. Now whether the directional derivative exists at 0 comma 0. That means your target is to find limit h approaches 0, f of ha, f of hb minus f of 0 0 divided by h. What is the condition on the a and b? Where a and b are the unit normal vectors. That is a square plus b square should be 1. Fine. Now you can substitute the value. Limit h approaches 0. What is the f of? Is a h x square into y. That is a h cube a square b divided by h4 a4 plus h square b square plus e raised to power xy, that is the h square ab, f of 0 0, the value is my 1 divided by h. Now that's you can, it's a very simple. Now you can separate them. If you separate them, h square will be cancelled out, so h cube will be cancelled out, so it is a square b divided by h square a4 plus b square plus e raised to power h square ab minus 1 over h. Is it fine? Now once you take as h approaches 0, this number will be a square over b plus this number will be my 0 by 0 form. So I can apply the L'Hopital rule. You say h square ab into 2h ab divided by 1. And when you take h approaches 0, this answer will be 0. So the answer is a square over b. Now you can check whether this is existence for all. You can see it is existence for all provided b is my non-zero. Fine. Now what will happen when b is equal to 0? What will happen when b is equal to 0? So based on this condition, if b is equal to 0, the value of the a is my plus minus 1. Then you can check the differentiability. Limit h approaches 0, h a, h b, b will be the 0. Fine. Minus 0 comma 0 divided by h. So h a comma 0, this number will be 0. So the value will be 0. E raised to power 0 is 1 minus 1 over h as limit h approaches 0. Answer is 0, which is also existence. So whenever b is a non-zero, limit existence. Whenever b is 0, limit is also existence. Yes, the directional derivative existence. So the answer is A, B and D are my right answer of this problem. Okay, look at this next one, which is related to the pointwise and uniform convergence. What is the shortcut tricks as I mentioned you in my real analysis lecture? How you can prove about the uniform convergence? Very simple. You can pick any element from the domain. You can pick any value of the x from the domain and prove that f of n is not goes to the 0. Fine. This implies fn is not uniform convergent. Fine. What is the domain is? 0, 1. You can pick any value of the x. Either you can pick 1 over n, or you can pick 1 over, or you can pick 1 plus 1 over n. But clearly say 1 over 1 plus n is lies outside the domain. Fine. So I can pick the value of the x is 1 over n. When you pick x is 1 over n, what is the value of the fn? It is 1 minus 1 over n raised to power n. So what is that? When n approaches infinity, this value will be 1 over e as n approaches infinity. So clearly say this number is not goes to the 0. That means this is not uniform convergent. So does not converges pointwise, does not converges uniformly, right options. Fine. Now, second is how you can check about the pointwise convergence. That means your target is to find limit n approaches infinity of the fnx. Now, since my domain is the closed interval, I can consider the three cases. If x is 0, if x is 1, if x lies between 0 and 1. Fine. Whenever x approaches 0, the value of fnx is 0. When x is 1, this value is also 0. Whenever x lies between 0 and 1. Remember student, always remember, you can't take this number. Fine. Because whenever you take 1 over n as n approaches infinity, this number is basically my 0 and you already consider the case. Fine. Now, this is the only case for the uniform convergent. So whenever you can take, how you can find the limit as n approaches infinity? Limit nx into 1 minus x raised to power n. So when you take, and you can see whenever x lies between 0 and 1, 1 minus x is also lies between 0 and 1, and when you take as n approaches infinity. This is my infinity, this is my 0. So that is undetermined form. So I can write this number is nx over 1 minus x raised to power minus n. Then it is infinity by infinity form. How you can find the limit? I can apply the L'Hopital rule. It is 1 minus x raised to power minus n log of 1 minus x as limit n approaches infinity. So what is the value when n approaches infinity? This value will go to the infinity. So that means this answer will be 0. So therefore, because the limit of the each function exists, so it is a pointwise continuous, and you can see this function is my continuous for all the values of the x. So it's continuous. Fine. This option is cancelled. So B and D are the right answer of the problem. याद रखो बच्चों, आप कभी भी ये नहीं ले सकते आप x is 1 over n. फाइन पॉइंट वाइज कन्वर्जेंट के लिए नहीं ले सकते, यूनिफॉर्म कन्वर्जेंट के लिए ले सकते हो, बिकॉज जैसे ही आप लिमिट n अप्रोचेस इन्फिनिटी करोगे ये वैल्यू तो 0 चली जाएगी. फाइन. अगर आप सोचो कि x की वैल्यू 1 over n लिया और ये फंक्शन 1 over e बन गया, फाइन, वो ऐसा नहीं है, बिकॉज वो यूनिफॉर्म कन्वर्जेंस के लिए होता है. पॉइंट वाइज कन्वर्जेंस के लिए आपको प्रॉपर लिमिट लेनी है. चलिए, लुक एट द नेक्स्ट वन. f is a continuous function which are defined here. I think that's one of the easiest question. What is f of 0? f of 0 limit is from 0 to 0. तो आंसर तो 0 ही आएगा. फर्स्ट ऑप्शन satisfied. Second option, derivative with respect to x. So can you find the derivative with respect to x? Fine, this is the here. So you can take the partial derivative. X is my 1, rest are my same. Fine. So again you can see, because g is my continuous function, so this limit existence. So that is fine. And what is the value of the f dash of the 0? Again you can see the limit is from 0 to 0. Answer is 0. So second option, correct option. C, second derivative. If you find the second derivative with respect to x, because this function is independent of the x, so I can use the Leibniz rule, that's a g of x. And g is my continuous function. Yes, this is my existence. And the value of the f double dash 0 is equal to g of 0. Third option is the correct. Fourth option is the wrong. A, B and C are the right answers. Always remember students, आप ये वाला लेक्चर जरूर सुनिए. रियल एनालिसिस, फाइन, रियल एनालिसिस लास्ट मिनट वीडियो. और अगर आपको यूनिफॉर्म कन्वर्जेंस के ऊपर लेक्चर चाहिए, यू कैन वॉच एज द यूनिफॉर्म कंटिन्यूटी, पीवाई क्वेश्चन ऑफ द कंटिन्यूटी, डिफरेंशियबिलिटी, यूनिफॉर्म कन्वर्जेंस के ऊपर सुनना है आपको, यूनिफॉर्म कन्वर्जेंस एंड मेनी मोर. काइंडली वीडियो को लाइक और सब्सक्राइब जरूर करिए. ओके, f is my monotonic function. Fine. Whether it's a monotonically increasing or monotonically decreasing. So that is anyone. Then, which of the following statements are true? Every monotonic function is a Riemann integrable. That's true. Every monotonic function is a Lebesgue measurable function. That's also true. Every monotonic function is a Borel measure function. It's obvious too. Fine. Now, look at the second point, whether the set of the discontinuities of the f cannot be the non-empty finite set. So always remember, first of all, whenever it's a monotonic functions, so what kind of the discontinuities they have? They have only jump discontinuity. Fine. Now also remember, if the monotonic function is discontinuous, fine, because they are not talking about the whether the function is continuous or discontinuous. So if the function is my discontinuous, or the monotonic function is discontinuous, say at one point, fine, then what does it means? Then the function f, that which is monotonic, if the monotonic function is discontinuous at one point, then f is discontinuous at infinitely many points. Fine. If the domain is my closed interval 0, 1, if the my monotonic function is discontinuous at one point, that is a jump discontinuity, then the function is discontinuous at the infinitely many point. And he also said cannot be the non-empty finite set. Yes, it can't be the non-empty finite set. So all A, B, C and D are the right answer of this problem. Okay, look at this another one. A n, B n, C n are given defined to you. So what I told you, whenever is a plus minus sign, you always take as n is even, n is odd. When n is even, this number is my here. When n is odd, this number is my fine. Now the sequence does not converge. When the sequence convergent, if the limit is unique, fine. So what is the limit? This value will be the 0, is a 1 or minus 1, which is not unique. So if the limit is not unique, that means sequence is divergent. Now, what is the limit of the supremum? You can see limit of the supremum of the an, maximum limit 1, and the limit of the supremum of the an is minus 1. Fine. Now, okay, fine. Then your target is to find the bn. Bn is my maximum of a1. What is the a1? N is odd. So it is my minus 1 over e. Fine. I can return this number is 1 like here. N is 2. 1 plus 1 over e square minus 1 plus 1 over e cube and so on. It's a 1 plus 1 over e 4 and so on. Fine. So can you find the maximum value? Definitely the maximum value be occurring from this space and so on. That is the maximum value is occurring from the even parts. So what is the maximum value? You can see because this function is my decreasing, so the maximum value is occurring at the first point. Fine. Now look at the Cn. Cn is the same value, but instead of them it's a minimum. Fine. So minimum is occurring definitely for the negative part. That is minimum is occurring at here. And you can see minus e raised to power minus n is my increasing function. So the minimum is occurring at this first point. Minus 1 plus 1 over e. Is it okay? Because all the numbers are negative. So this is the value of the increasing. That's the maximum value. Now look at the limit of the bn. So what is the limit bn as n approaches infinity? This is the same case. It is independent of n. So this number is 1 over e square and this number is minus 1 over e, which is not same. Limit of the bn, while the limit of the supremum is 1, this option is cancelled. Only A option is the right answer of this problem. Look at this next one. Positive real number, x is 0, f is continuous, f is and so on. You can see when x is 0, look at that this case, x over mod x. It is positive value. If x is my positive, it's a negative value. If x is my negative, fine, and 0 when x is 0. So clearly say this function is my continuous at 0 comma 0. Fine. So first option is the correct options. Now whether it's a differentiable or not. So firstly we can check about the partial derivatives. Partial derivatives at the 0 comma 0. That is a limit. H approaches 0. F of x comma 0. F of 0 comma 0 divided by h. So this is limit. So x is y is equal to 0. This number is my x over mod x, or instead of taking as a h, you can write here is x also. So x over mod x, this is x square. Whenever y x is equal to 0, the answer is 0 divided by x. Fine. Now root of the x square is mod x divided by mod x. So the answer is 1. Can you find the partial derivative with respect to y? So this will be limit y approaches 0, f of 0 comma y, f of 0 comma 0 divided by y. Whenever x is 0, this answer will be 0. X is 0, this answer is 0. So therefore, this is my 0. Both the limits exist. Yes, this option is the correct answer. So what we have obtained, partial derivative is 1, partial derivative of y is 0. Now, check about the differentiability. at the point 0 comma 0. So this is I called as h comma k, fine, minus f of 0 comma 0, which is equal to a times partial derivative x plus b times partial derivative y plus some function of the hk root of h square plus k square. Fine. What is h comma k? This is my h over mod of h into h square plus k square. Whenever x is 0, the answer is 0. Fx is my 1. Fine. So instead of the a and b, I can written here is h and k. Minus of h, this value will be 0 divided by root x square plus x square. Fine. Now your target is to check whether the limit 0 0 existence or not. So you can see I can separate them. It is h over mod h minus h over h square plus k square. Clearly say the limit does not exist. Why? Because when you take h is positive, then it is a plus 1, otherwise minus 1. So once the limit does not exist, that means the function is not differentiable at 0 comma 0. Fourth option is the correct, third option is cancelled. A, B and D are the right answer of this problem. You can see this is a function of the several variables, and you must watch about my this lecture, function of this several variable differentiability. You can watch my this lectures, this lecture, that will be very beneficial for you. Okay, look at this next question. X is my 0 comma 1 is a continuous function, u of 0 is 0 with the supremum norm. Capital T is a mapping, is a function from u of t. This is my define. Capital S is a map, is defined as a collection of all those images of the t of u. Norm is 1. S is unbounded, S is a bounded, S is a closed, and so on. So your target is to calculate. What is your target? S. S means your target is to calculate the images of the TU. TU is the collection of the norm of U is less than equal to 1. Fine. What is the norm of U? Supremum of this. That means U of X is less than equal to 1. Fine. That means minus 1 is less than equal to X is less than 1. Then I need the target of the T of U. I can integrate from the 0 to 1. Fine. So the left hand side will be my minus 1. Right hand side will be my T of U. This number is my 1. So that means absolute value of the TU is less than equal to 1. That means S is my less than equal to 1, which is my bounded. So first option is S is unbounded, cancel out. S is a bounded subset, that's fine, but whether the supremum is 1, because it is bounded by 1, so definitely supremum of the S is my 1. So that option is also correct option. Now look at this. S is a closed and there exists. Okay, there exists S is a closed. So that means S is my minus 1 comma 1. It is a subset of the R. Now whether it's a close or not, when it will be the close, we will check whether the endpoint exists or not, whether the endpoint lies in the S or not. Fine. So firstly we will see T of U is my 1. That is whenever S is equal to 1, that means T of U is 1. ये कब आएगा T of U 1? That means 0 to T is my 1. Fine. So this means U of T is my plus minus 1, because आपको सुप्रीमम कहाँ लेना, आपको एब्सोल्यूट वैल्यू पे. So that is a plus minus 1. Fine. Now U of T is plus minus 1. Is it possible? No. Why? Because the function U of 0 must be 0. So that means T of U can never be plus 1. Fine. Similarly, T of U can never be minus of 1, because if it is minus 1, it is minus 1, but we can take on the absolute value, it is not possible. So therefore, S is basically your open interval and it is a subset of the R. Is it fine? Now you can see this is my open, fine, but the last option said S is my closed. Third option said T of U is my 1, but T of U can never be 1. And you can see the supremum of S is my 1. Fine, maximum is not a 1, but supremum is 1. So the correct option is only B is my right answer of this problem. So you can see that all these questions that I have explained, all are the simplest way. इससे आसान तरीका I don't think so कोई होगा, because हर क्वेश्चन को मैंने simplest way से explain करा. You must watch about my these all lectures if you are interested to learn deeply. Fine. और अगर आप बाकी lectures देखना चाहते हो, you can see all these lectures are available free of cost in this playlist. मैं उम्मीद करता हूं आप वीडियोस को लाइक एंड कमेंट जरूर करेंगे. We will see the very soon the next lecture on the other topics such as because these lectures are already uploaded, we will see the next lecture on the complex analysis and the differential equation very soon. Till then you can share this video. Don't forget to subscribe my YouTube channel. Happy learning always. Thanks for the watching.